compound objects are just a combination of elementary or primitive objects. So combination of like we have, or like we are given in the tables book. So it might be something like, you have a rectangle on top of a triangle, on top of a triangle, and so you'd be told that this length, what the value of that length was, and what the value of that width was, and you might be given the angle, or so you might be given that. So what the length of those sides are, so that you'd be given enough information that you'd be able to work out what the area of that triangle is, and you'd be able to work out the area of that rectangle. So that would be width times length. That would be, well, depending on what the numbers were. So you might be given actually the length of the three sides of the triangle, and then you'd be able to use the formula to tell you what that area was. So that's pretty much all there is to compound objects. So if you know how to get the basic, the elementary ones, so if you know how to get the area of the triangle, the rectangle, and so on, then it's the same thing. A slight variant would be that where you're given maybe a rectangle, maybe a shape like that. So then you'd need to look at that and go, oh, that's a rectangle with a triangle removed. So you'd have enough, you might be given the width there and the length there, and you're told that, again, I'll call that distance x. So since you'd be given them, I'd say instead of having a variable, you might be told that's 5, that length is 10, and that is 2. So then from that you'd go, okay, this rectangle area is 10 times 5, because it's width times length. But then you've got that triangle, this triangle removed, and it's a right angle triangle. So then I'd go, that length is 5, that length is 2, so it's half a triangle. So triangle is a half times 5 times 2, because a triangle is half the area of that rectangle, which has width 2, height 5. So that area is equal to 5. That's the shaded area, and we want to know what is the area of the rectangle minus the area of the triangle. So then area is 50 minus 5, which is 45. And here we just looked at 2D, but 3D is basically the same. So you just look up the tables book and you look at what the volume of, whether it's a cone or a sphere, some kind of one of those 3D objects that we know how to deal with, and we just work them out, because you have all the information. You'll be given all the information that you need. So that's compound objects. Another thing that might come up is equivalent volumes, or maybe areas as well. So the idea there is, an example of that would be, say you have 5 balls or spheres of ice. So 5 spheres of ice, or it could be called, it could be some metal, and it's in this rectangular container. So again, say that's the width there is 10, and that is rectangular, as I said. So it's like a cube. So that length is 10, and that length is also 10. So it's 10 deep. So the question would be, when these 5 spheres of ice, radius 5 meters, so I'll say this is 10 meters, and that was radius 5 meters. If these melt, how high will this rectangular container fill? So it's that kind of question. It could be that it's a metal, 5 balls of metal, and they melt. So the essential question is, when that volume is converted into liquid so that it becomes reshaped into a rectangle, how high would the rectangle be? So if you have 5 spheres of radius 5 meters, then the volume is going to be 4/3 pi r cubed. So that's going to be 4/3 times pi times 5 times 5 times 5. So that's 125, and we have some number. I'll just call that V spheres. Then we know that the box volume is equal to 10 times 10 times that height. So I'll call that H. So the question is, what is the value of H? So that's going to equal 100H. So then that's a very simple equation. 100H is equal to V spheres. So then H is equal to V spheres over 100. Typically, actually, you wouldn't say that the spheres have radius 5 meters. I'd say that the volume of that sphere, like a better question would be volume of a sphere is equal to 20. So then 5 spheres would equal to 100, and then when I did this same equation, I'd end up with h is equal to 100 over 100. So then h would equal 100 over 100, so it would be 1 meter high. By saying that the radius is 5 meters, I end up with v spheres. That's a messy expression with pi in it, so I'm not going to it is going to be, so 5 times 25 is 125, times 4 is 500 over 3 pi. So I mean, it's an answer. And it's v spheres over 100, so it'll be over 300. At least the hundreds cancel, so I'll end up with 5/3 pi. So just doing that again, since it's a bit messy. So v spheres is 5 times 125. That's 125 times 4. So that's 500 over 3 pi. So that's what we have here. V spheres is 500 over 3 pi. Now you divide that by 100, so that becomes over 300. That's a lucky break, so I can cancel I can divide top and bottom by 100, so my answer is 5 over 3 pi. So if I had 5 spheres with radius 5 meters and they melted, and they were in a box with dimensions 10 meters by 10 meters, then the height that the melted water would reach is equal to 5 over 3 pi meters. So that's the second type of question we wanted to be able to deal with. So looking at compound objects and equivalent volumes. They're pretty much all we'll be looking at. So finally, we're going to move on to the trapezoidal rule.